Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to take a look at sequences and series. And this is actually a part two, but rest assured that if you missed part one, no worries. Dennis and Kim are ready to go. With that, my name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. And with us tonight is Dennis Wilson and Kim Thomas. Dennis has been teaching at Landmark Christian School in Fairburn, Georgia for the past 26 years. He is currently the mathematics department head for his school and teaches honors pre-calculus and AP Calculus BC. Dennis is an active member of the Georgia Council of Teachers of Mathematics and presents annually at their state conference. He's also served as an AP reader for calculus for the past 6 years and formerly served as the president of the Georgia Association of AP Math Teachers. So Dennis, it's great to have you with us.
Thanks, Mike. I'm excited to be back.
And Kim is a national board certified teacher in her 27th year of teaching high school mathematics. This year, Kim is teaching AP Calculus BC and Geometry at Moon Valley High School. She has 6 years of experience also as an AP Calculus reader. And in addition to teaching, Kim works with math teachers in a variety of professional development environments, promoting student exploration, understanding, communication, and engagement. Kim, thanks for joining us tonight.
Happy to be back.
At this point, Dennis, would you mind talking through our agenda for tonight?
Sure, Mike. Tonight, now that we've gotten through the welcome and introductions, we're looking to take a little bit deeper dive into sequences using both the TI-84 plus CE and the TI-Nspire CX2. And what we'll be hoping to do is to explore the features of these calculators through activities that kind of plant the seed for calculus later on. So we'll be using student-created data to explore relationships between exponential functions and geometric sequences. We'll use the context of credit card payments to apply sequences to solve problems. And we'll use the context of area of inscribed polygons and circumscribed polygons to apply sequences to solve problems. And then when we're all done, we'll have a webinar drawing for a free calculator.
Thanks so much, Dennis. And Kim, would you mind talking through our expected outcomes?
Of course. So our expected outcomes is we're planning on making sure that you can have the skills to plot data as a scatter plot and sequences using the sequence mode on the same TI screen, no matter which calculator you use. And we're hoping that we can apply sequences in a finance context to solve problems. And we're also going to continue exploring different contexts using sequences to make that connection to calculus, whether or not students are in calculus or not.
Awesome. Thanks, Kim. Tonight we'll be using the chat window to send general messages, but feel free if you have any questions at any time for Kim or Dennis, use that Q&A window on the right side of your screen. At the end of the webinar, we'll be sharing a link to download tonight's certificate of attendance. With that, Dennis, let me give you control. Feel free to share your screen.
All right, thanks, Mike. Whoops. Thanks, Mike. And tonight, the first thing we're going to be looking at is an activity that kind of hints back to what we talked about back in the fall in terms of just getting everybody familiar with graphing sequences once again. And we're going to do so with an activity that explores exponential functions. Now, I don't know if you guys, where everybody sits and where sequences might fall, but I teach pre-calculus and my students come in with quite the misconception with what an exponential function is. They're constantly thinking that if it's not a line, it's exponential. So much so that I had to put a poster up in my room that looks like this. Exponential, you keep using that word. I do not think it means what you think it means. And so what I what I want to look at is the activity where I try to introduce students to the idea that exponential functions are quantities that grow at a rate proportional to their value. And so you may have seen some of this activity before, but this is a standard M&M activity where my kids have a cup of M&Ms and they take that cup out of that cup and they put 2 M&Ms into that container. And then they close that. Well, first of all, I just mentioned they need to make sure that those M&Ms have imprints on them. That's important. But they put them in and then they shake the box and let the M&Ms come to rest. And then they're going to count the number of M&Ms that landed with the imprint face up. So about half of them should land half face up, but then they multiply that number by a half because I'm not wanting them to just get half. I'm wanting them to think about how much it might be growing by. They'll add that number of new M&Ms to the box from their cup, and then they'll keep doing that until they get their container that you can see here full. And so as we move tonight, I've already got the data in a TI-Nspire calculator here. And so what I'm going to do is I'm going to go to the list editor by pressing the stat key. And the stat key has the edit menu. And when I click enter, you can see that I have 4 lists of data here. And in this first 2 sets of lists, I've got L1 and L2. This is actual student data that my students collected on the M&Ms. And you can see that before they had any trials, they started with 2 M&Ms and they continued to do the activity, repeat until they hit 271. And so what we want to look at tonight is being able to plot this data in a scatter plot, but at the same time plot a geometric sequence using our sequence mode on the calculator. And the reason I want to look at it with a sequence mode is because we're looking at discrete data here, and I want my students to connect that there is something discrete that is growing, and it's growing because we're multiplying by, while it's a little bit random, but almost a constant rate. So I've got this data in, and so what I want to do is go and plot it. So I'm going to go to my y equals, and L1 and L2 by default are the plot ones. So I'm going to go up to plot 1, hit enter, and at this point, as a teacher, you got to make a decision as to how you want your kids to go ahead and plot the data. Now, my window is just in the normal graph window, so I'm not going to see all that M&M data because I'm in the standard zoom window. So depending on what my learning focus is, I might zoom and fit the data, or I might ask them to set up the window based on the data we had. But for tonight, I think we'll go ahead and we'll zoom data for the sake of time. So I'm going to go zoom, and I'm sorry, zoom 9 for zoom stat here. And here's the data, and we can see that's a pretty nice fit to what we expect for an exponential curve. Okay, so here's the review of what we did before, though. Now I'm going to switch to sequence mode. So I'm going to press mode on my calculator, and I'm going to go down to the line where I have function, parametric, polar, and sequence. And the quick way to get to sequence is just to push to the left. And once sequence is flashing, I'm going to press enter. So a lot of things change once I change this mode. When I press y equals now, my window looks very different than it just looked before, where I had y1, y2, all the way to y0. I've got 3 functions here, u, v, and w, and they're all functions of the variable n, and n can only be an integer here. Okay, on this window, I can plot different types of sequences depending on where I want them to start, and we'll look at that tonight. And I can choose with what n I'm going to start with. So for our M&M data, we started with 0 trials, and I know that I started with 2 M&Ms. So there's our initial value, and I want to multiply it by some number that's going to be repeatedly multiplied. So if I'm getting about half of my M&Ms to come imprint up, and then another half of my M&Ms I'm going to add half of that number. So half of a half, I'm expecting my students to hopefully realize that they're increasing by 25% here. Now, I start this activity actually with a warm-up that day, and I ask them to calculate the cost of an item that is on sale and has tax, so they can remember that the best way for them to do a percentage increase is to multiply by 1 and then the percentage increase. So I'm going to multiply this just by 1.25 and kind of see what will happen with my data as I raise that to a power. So when I raise this to a power, I'm going to come to the xt theta n key. And one of the differences, again, I'm in a new mode. That x on the key is for function, t for parametric, theta for polar, but I'm in sequence mode. So when I press this button, I get n. So what I have here is a nice explicit geometric sequence, and we're almost ready to graph. Okay, but let's look just for a second at the window here. And can you see what's a little bit different in this window setup? If you're familiar with the function key, we have some, the function mode, then you see we have some different options here. We have n-min, n-max, how many terms of the sequence we're going to look at, and then we can even change where we start and stop the plot. Well, I've already somebody asked, how did I get U0? And that's because my n-min is 0. So if I go up here, you can see these values U0 and U1. I'm not necessarily using them in this particular one. In the next activity, we'll make changes to these values. But if I hit 1 here, it starts with 1 and 2. If I change n-min to 3, I get 3 and 4. And so because my students had trial 0 in their table of data, I'm going to start with 0. And so you can see the window, that n-min in the window is the same n-min in my y equals. And now I'm just going to go ahead and graph because I had it set up to the data I already had. And there's my sequence being plotted along with it. So you can see I'm a little bit less. And so this is a great opportunity to create conversations about how much is that percentage increasing? Why might it increase if there is a 50% chance that those imprints are going to land up? What's going on here? But there's some good opportunity for them to at least see that every time we shake that container and add M&Ms, that number grows as the number of M&Ms grows. So at this time, Kim's going to look at the other side of this activity using the TI-Nspire. Turn it over to Kim.
So this data is coming from Dennis's class. It's a fun activity, one that I'm sure some of us have done before with this. So let me go ahead and share my screen. So in Dennis's classroom, he did this in a block schedule, and he can correct me if I tell the story wrong. And after part A was the exponential growth, right? And so the students are collecting data, they have their M&Ms in the container, and now we're going to do the decay data collection. So after completing part A, we have a total in the container. And what we're going to do with this is we're going to shake the box and we're going to let the M&Ms come to rest still. And this time we're going to remove the M&Ms that landed without an imprint and record the remaining M&Ms. So now we can see that we're taking out of the box and we're keeping track of
And Kim,
to
let me
record
just
that
say it's important that you remove the ones that don't have imprints, because there are M&Ms that don't have imprints on either side. So if you're taking out the imprint ones, eventually your kids just keep shaking the same M&Ms over and over again.
And that might be part of
Sorry,
the
Kim.
reason that that might be part of the reason why the data was a little bit off from our expected model
Our
in the
expected
first time,
growth, yeah.
depending on how many M&Ms have M's on them. So we're going to remove those and we're going to record them in that table. And we do have that data here for you. And this is already pre-done in my TI-Nspire here. This is my TI-Nspire software. Let's go ahead and put the calculator up there for you. And we can see that this particular student group took 0 to 9 trials, so 10 of those to get to 0. And so just kind of looking at that data that they put into their data table here. What's really important with the Nspire is that you name the columns when you're working with this sequence, with the spreadsheet, so that we can recall up these variables. So what we're going to do is we're going to add a page to this, and there's so many different ways to add a page in Nspire, but I'm going to go ahead and do Control Doc. That gets me plus page. And we're going to do the same thing. We're going to go ahead and graph this data as a scatter plot, and then we're going to graph the sequence on top of it. So that means I'm just going to go ahead and add a graph. Here's my window. And this top line right here is called the graph entry line. And to change the graph entry line, the shortcut when I teach my students is to hit Control, then Menu. And up here, it'll say, hey, what do you want to do with the graph entry line? And we have all of these options. And one thing that's beautiful about BC Calculus is that we actually use every single one of these options within the course of the school year. And it's not something that's just waiting out there. So we're going to go ahead and do a scatter plot, which is number 6. And now you can see how this changed. So what's going to go along my horizontal, which is in the X's, what's going to go along the vertical, which is in my Y's, it's saying it's scatter plot 1. And I could type in the titles if I remember what those titles were. But I also have this variable key, VAR, sitting right there above the 9. I'm going to hit VAR, and I have to decide, okay, I named the number of repetitions. That's going to be my input, and it brings it up, and I know that it recalled it because it's bolded. I'm going to hit my down arrow. I'm going to do the same thing. And I could type in count, but if I spell it wrong, there's that issue. So it's really nice to have it brought up for me. And then to pretty please graph this, I'm going to press enter. And so just like in the previous example here, we have some data, but this was our standard window. I know that I just kind of moved it a little bit, but I still don't have everything. So if my students collected their data, they might know that we need to change it to 271, at least 271 up here, or we can just go ahead and press menu, change our window. And on the Nspire, we have zoom data and we also have zoom fit. I'm going to try zoom data, and there's zoom data, which is a pretty nice exponential decay curve, which we would have expected. Now we want to put in a sequence that's explicitly defined for this as well. And with the Nspire, we don't have to change a bunch of different modes. We actually just have to bring up that graph entry line here. So I'm going to press tab, and I'm going to be sitting here in scatter plot mode, and I need to change that. So how do I change that? And hopefully we're remembering Control Menu, change the graph entry line, and this time I would like to change this to sequence. So we're going to go into sequence mode, and now we can see that we have our U's, just like we had on the 84, except everything is going to be a U. We're not going to have a U and a V and a W. And we have these step sides here, so everything's kind of contained within this one little rule. So for this exponential decay, we're going to start with our initial value. So this particular group had 271 M&Ms to start out with. And we were doing half life basically, so decay. So I'm going to multiply that by 1/2. And I'm going to raise that to my n power. And our initial term, we don't need an initial term here because this is just going to calculate it. And we do want to start this at 0 because we had trial 0. So this is the key where students need to kind of pay attention to, like, how many of these do we want to do? And so we're going to go ahead and start this at 0. And here's the one, here's the other one. And you know what? I'm going to change this color real quick just so that we can see it a little bit better. The one disadvantage of using the control menu and having 2 different types of graph on the same screen is that each time you start over, you're going to start over with your colors. So they're always going to start in blue. So you do have to go back and color that in. And we can see this matched up really well, especially on the ends. even more so than the exponential growth. So were there any questions throughout all that, or is everybody looking pretty good?
Haven't had any questions on using the calculator,
Okay,
but like we're ending up with fractional values of M&Ms in our model. Kim, you want to go ahead and just like show them how we could trace like
absolutely.
through that sequence?
So we're going to hit press menu and we're going to hit trace, graph trace. And right down here, we can see we're on the scatter plot, which was our collected data. And just like our TI-84, if I want to switch to the other graph, I'm going to hit my up arrow. And now I'm on that calculated model. And you're right, that it's a model. It's not exactly what happened because I hope our M&Ms didn't break. I wouldn't like broken M&Ms in my data piece, but we do have that piece right there.
So how do we talk about that? Like when our, we're talking about something that's definitely integer values in terms of our activity, but our model will only give us, yeah, will give us real values, rational numbers. That's something you should want to be ready to talk about and discuss, that our model's only going to be so good that it is a model and it's an approximation, I think.
And I think what you bring up too is also a very, very important piece is that I'm going to escape out of this quickly. But typically, like what's nice about this one is I can put all three on here if I want. Typically we do the 271 and then we would do 1/2, and then I'm going to have to do x minus 1, right? No, I can
No,
just do
X.
x. I could just do x in here,
So
getting all my counts in there. Typically we just put that curve in there, which has all of the discrete points between that and makes it look like it's continuous, and we definitely didn't have continuous data. So I think that's the other important connection to make with students and say, should we have connected those? Why or why not? Especially if we do this activity with younger students who haven't even explored that. So
yeah.
that's a good point to bring up.
And that's one reason I like doing this as sequence instead of the exponential function so that, what does it mean to have a fractional number of trials? We did 2.5 trials. Well, that doesn't really make as much sense. And I'm not quite ready to leap into raising a number to a half power and talking about exponential rules. I'm just trying to let them understand the M&Ms grew or decreased, and it was based on how many M&Ms I had in the box. Now, you talked about fractional M&Ms. I did have one group, and the guy was just super excited, and he would take that container and he'd shake it super hard. He wanted to make sure that he got the M&Ms mixed up really well, and then in the end, like there were just pieces of little M&Ms all over the place. So you get all kinds.
Yes, that definitely will
Yes.
happen. Cool. All right. So I
All right.
think that concludes our student generated data with our M&Ms. And so you are ready to go ahead and are we about ready to talk about money?
I think we're about to talk about money. We talked about food. The next thing on the list has to be money. Got
Okay,
to pay
I'm
for
going to
the
pass it back
M&Ms.
to you.
All right, so I
Money's
will
always a good thing to talk about after food.
share my screen. So the next thing we're going to talk about is credit card debt, and unfortunately, it's a common problem for Americans. It was a common problem for my own family earlier in our lives, and this situation is talking about a student who's in college and something unexpected happens and that student has to max out the credit card. And so in this scenario, student has a credit limit of $3,000. The credit card is charging 36% APR, and it's a little bit higher than a credit card might charge, but I like giving the students a number divisible by 12 since we're paying per month. And then in this scenario, the credit card company's going to charge a minimum payment of either 8% of the balance or $50, whichever is least. And so in the activity, they're going to have to figure out at what balance does it switch from being 8% to being $50. And I'll just go ahead and say right now that it's going to be at $625 where that'll change, and that'll be important as we look into this. Okay, and so the students start out, and I'm just having them grind out the numbers. It's almost like they're their own little personal spreadsheet in Excel, and they're going line by line with their calculator, computing. Okay, this is my starting balance, this is the payment, this is the finance charge, and then they subtract the payment, they add the finance charge, and then they get the value. And then they take that value, and this is the important thing I want them to see, is they're taking that value that they've come up with and they're starting the next month with it. So there's an idea here that's important to students, and it's recursion. Recursion happens in Euler's method for calculus. We see it. It's the power behind spreadsheets. Students going into computer science have to become very familiar with it. But this is all that's happening. And I want students to grind it out because I want them to realize there's got to be a better way than just sitting there and calculating the numbers. And I want my students with technology to recognize that the calculator is a tool to explore math, to learn math, that it's more powerful than just adding, subtracting, and multiplying numbers. And the second thing one of the big things I want my students to walk out of my class with is the idea that they become lifelong problem solvers. And so this is a very real problem that they might face. Okay, how am I going to pay off this credit card? How long is it going to take? What kind of plan can I have? And I want to kind of give them the same tools, the tools that they need while teaching them the math. So,
And I think one thing
go
that
ahead,
this
Kim.
chart also does is it teaches them kind of like the organization with it. And can they figure out what the chart means once they just fill it out? Because
Yeah.
sometimes students will
Mhm.
just crank through the numbers and not really think about what they're doing. And it's so easy to just Google something online, but if you don't understand what you're looking at and if you can't interpret it, just because the computer said so doesn't mean that it's the right answer. So that skill of cranking this out the first time and creating a need is real important.
Yeah, I remember when I went to buy a house for the first time and I'd forgotten how to calculate a mortgage payment, and like I wasn't getting the numbers they're getting. How are they possibly getting this numbers? And it was like, okay, I have a degree and I have to go back and learn a little bit of math to do it. But I could puzzle through it because I pretty much did the same thing. But the key thing, like she's saying, using this chart to find out what's going on. And so it becomes a recursive sequence, and the students in the activity come up with the fact that the next term in the sequence, the amount of money I owe the next month, depends fully on the amount that I owe this month. And so you can see it takes this month's um, balance, subtracts off the payment I have to make, and then adds on the interest for the credit card. And then because it's recursive, I can't just throw this in. The calculator needs that initial value. So this time we're going to see that initial value, and we are going to change from n starting at 0. We're going to start it at 1. So I'm coming back to my calculator here, and I'm going to turn off the plot. So I'm going to go to y equals. I don't need this M&M data getting in the way of my credit card. So I'm going to turn off the plot. The next thing I'm going to do is I'm going to come down here, and you see that sequence of n is flashing. And what that means is u, v, and w, which is below, are all functions of n. I'm just going to move over where I've got sequence of n plus 1 and hit enter. And you'll notice now I have u of n plus 1, v of n plus 1. So this is going to take u of n plus 1 and allow me to find it with reference to the previous value. Okay, the chart the students are using starts in month 1, so I'm going to put that as a 1 there. And the variable, I need to put that function in that I saw right here on the screen that the students had derived. Okay, so I'm going to clear out that. And to get what u is, I'm just going to use the shortcut of alpha trace. So on the TI-84 plus CE, alpha trace will give me the sequence variables if I'm in sequence mode. Okay, if you're on an earlier model of the TI-84, you might have to actually use like you can see it right above the 789 key. The second 7 would give you that u, but I'm going to use u of n plus 1. Alpha trace is giving me un, and then I'm going to subtract out the 0.08, and I've got to multiply that times the un. So once again, alpha trace to get U of N, and then plus the credit card's going to company's not going to take away the interest. They're going to add on. So plus 0.03, and then once again, I'm going to alpha trace and UN. So
And
this
Dennis,
sequence,
just as a
go ahead,
reminder, just in
Kim.
case
Yeah,
anybody's thinking about this, the 0.03 wasn't in your words. So remember in the
yeah.
formula, I'm going
So
to let you
that's
explain
one
it.
reason I gave them on the, no, go ahead. The one reason I gave them the first line in that chart so they could see there's that 6% interest, but only 1 month is going by. And so I'm only getting charged 3% because that's 1/12 of the 36% that I'm getting.
And I would bet that some students would still use 0.36 times 1/12, and some students would figure out, oh, I can simplify that. And even
Yes.
more important for kids without a lot of experience, I can't touch that 3,000. That 3,000 isn't moving. I know it is moving, but not within that line. Like I have a
Yeah.
$3,000 bill right now. So just wanted to point that out, just in
Yeah.
case anybody
No,
was
no, that's
wondering where
great.
point
Yeah.
oh 03 came from.
0.03. So this sequence we're going to use to give us what our balance is each month. And I've got, because the new balance depends on the previous balance, I've got to give it that first balance of $3,000. Okay. The other thing I'm going to do is I'm going to come down to V of n plus 1, and I'm going to accumulate how much I pay off. So V sub n plus 1, this is the amount I pay. So I'm going to start by pressing alpha trace. I'm sorry, I'm having a little bit of trouble with my smart pad. I'm going to press alpha trace. I'm going to press down to get VN. So I'm going to take the total amount of money I've accumulated so far and add on how much I make in payments. And so I'm doing 0.08 and times, and here I'm just going to refer to the other formula because the amount I'm paying is the amount that I'm subtracting from my balance. And so this column, this sequence V, is going to add up how much I paid. So if we think about it, how much did I pay to very start? That's 0. So now I've got two sequences. One of these hopefully is decreasing. That's my balance. The other will be increasing. That's the total amount of money that I've given to the credit card company. And so once again, we're going to go to our window and we're going to make a choice. Earlier, I asked for input on which scenario that the teacher might use to choose to Zoom or whatever, and I got Zoom data. Okay, here we don't have the data on, but I do have Zoom Fit, and when I do Zoom Fit on the Inspire, I'm sorry, on the 84, it's going to fit those in values. So I'm going to go ahead and I'm going to hit Zoom and 0 for fit, and I only get so many dots, and we'll see why in a second. Okay, but I can trace these values, and you can see I start off with 3,000, and the next week there's that 2850 we saw in the table, and these values should start matching those first 5 in the table, and then the students are seeing, okay, the calculator is going to through that sequence of calculations much quicker than me. And then we can also see that not only that, but it's adding, this one is adding up that column of minimum payments I'm making each month, and I can see that here I am 19 months in, so just a little over a year and a half, I've almost paid back $3,000. Wait, didn't I borrow 3,000? I
Yeah, but
borrowed
wait, you still have
3,000.
a lot more
Wait,
to owe.
I still have 1,200 to go. Does that even make sense to a student that they would borrow $3,000 and then year and a half later they're still not quite there? And that's exactly what's happening. So right now you might ask your students, you go, okay, we're only a year and a half in, and I like talking in years, especially with high school students. A year is a long time for a high school student. You know, for me, a year, oh, it just blink of the eye anymore. But for a student, a year, I mean, that's the difference between freshman and sophomore, junior and senior. So year and a half here, they're not quite paid off. I'm asking how far into the future. And so what they need to do We're going to go to the window, and all I'm going to do is I'm going to increase the number of payments that I'm looking at. So this only went 19 months in because my calculator was set up for that M&M activity, but I'm going to go forward to, let's go 3 years. So 36 months into the future, 3
Now,
years, almost
Dennis,
all
you
of high
said three
school. Go ahead,
years
Kim.
though. Could you just do 3
Okay.
times 12 there?
Can I just do 312? Wait, does the
Three,
calculator calculate? Is that what you're telling me? Hold on,
well,
times
that's what
12.
I'm asking.
Three,
Because if you're talking in
well,
years,
so 3 times 12, and let's see. I just press down and it's automatically 36. And students, that blows their mind. I have seen students, I have to come over and go, wait, don't go back to the home window and do the calculation. They'll they'll go to their calculator, they'll go second quit to go home, they'll type in the number and then they'll put it in their window. The calculator does it all right there. Thanks, Kim. That's a good pointer. So now I can zoom fit again. There's my picture. Look, I'm well above. After 3 years, I am well above that original amount I paid off. Okay, so what
and I
the
love
students are
seeing
trying.
the
Go ahead.
big difference between the two graphs. Because I know
Hmm.
typically I just look at a spreadsheet and that spreadsheet, well, I got these numbers there, I can subtract them. But I like seeing that big difference between them. It's such a
Yeah.
great visual.
Hmm. So now I'm going to trace, and what the students are looking for is that moment when the balance drops below that 625, when the minimum payment becomes $50 instead of the 8%. And they go all the way out here to month 32. Month 32. So that is over 2.5 years into the future. They're finally down below the 50% mark. I mean, the $50 mark on their minimum payment. And at this point, the sequence is going to change. No longer are they going to pay a percentage amount off. They're going to start paying $50 off. And then up here, this is going to change because instead of going up by a percentage and looking at that exponential climb, that asymptotic behavior, now we're just going to take 50 off each time. So what the students are going to do is they're just going to come in to their y equals, and we're going to change that sequence. And these numbers are all in the activity that you'll get at the end. But all they're going to do is we're going to jump forward to month 32. So that's my new minimum for the sequence. I'm going to go down here, and I'm going to change this. Instead of subtracting the 8%, I'm going to subtract $50 each time. And then the balance at that time was $611.25. Oh, nope, 72 cents. Sorry, 72 cents. And then I'm going to change this. Instead of adding on a percentage, I'm going to add on the $50. And then I'm going to change this number to the balance that we had at month 32, which is 3,800 and we're $821 over what we put on that credit card. And sometimes things happen and you have to. And what we're trying to get the students to realize is um, the power of how much they pay back. But right now, 3.5 years in, $821 more, and we're still paying. Okay. And so when I go here to window, 32 to 36 won't quite get it. Let's go a little bit more into the future. Let's just go and see what's going to happen at the end of 4 years, at the end of their high school, at their, say that happens their freshman year, what happens by the time they graduate college. And when I press graph, whoops, I got to zoom fit again so that I fit that data. And we can see that it's starting to taper off. And if I trace the graph, I'm just going to type in 48 and go there. At 48, that fourth year, I'm finally below. And so they have to go back and see at month 47 that they still have $23 left to pay. But at that point, they paid well over 50% more than what they borrowed. And what I like students seeing here is this accumulation is no longer that exponential decay coming to a horizontal asymptote. This is now a linear function because we are adding on a constant amount every time we've got that arithmetic sequence going. So that's the hard way, the long way to pay off, and now Kim's going to look at the same stuff on the Inspire with the easier, probably more wiser way to pay this off. Pass this on to Kim.
Right. So we're gonna start right where Dennis left off. So this is what it looks like on the TI-Nspire, and we just put this stuff into our graph just like he did. The difference is that when we press that tab there, I'll go ahead and go to U1 there. We have to write the rule right here. There's our initial terms. And then when we're talking about those steps, like I just left it at the default and did 1 to 99, which is a lot, but we definitely see that exponential decay
So
right here, and then we see the curve.
how'd you get that
Yeah.
N+1 there on the Inspire?
Oh, so you just typed it in.
You just type it in.
You
That's
you just
nice.
type it in. Like you have to know what you're doing. So this is where it's really important to understand. So this is my U2 where I'm accumulating how much I paid. So if I say, okay, I'm going to start with how much I have, and then I'm going to add 8% of what I have, and the next term is one more, I just type in +1 right there, and it just works. So there's no special buttons necessary to press other than the control menu to get the sequence mode, to get the sequence graph. And everything else is just type it in. And it kind of makes it a lot easier. It kind of makes it so that we don't have to think too much about it. But it's not intuitive for students that I can just type that in until they've done that once or twice. It's not intuitive for teachers to do that.
Oh,
If you want 2
yeah.
terms ahead, then do +2.
And if you're new to the Inspire as a teacher, it's very not intuitive. You're
It's
looking
very
for a
not
button push.
intuitive. Yeah. So here's that situation. And the other piece to the activity is saying that, okay, Timothy has a situation and he decides that he doesn't want to do this. He calculated all this stuff out, and instead he would just like to pay $250 every month. He doesn't want to pay the credit card rules of the 8% until he gets to a certain piece and the $50. He just wants to go straight up to 250. Yeah, $250 each month. And so what's really nice about the Inspire is that we can have this conversation with students, we can have the story going on, and what happens if we just change that? And so which part of this equation up here would then change? And that's this piece about the 8%, right? So I'm just clicking into it, and I'm just going to go ahead and back this up and delete out the 8%. And instead, I want to do $250. And so I want you guys to think about what should happen with my curve once I do that.
We get some
And
suggestions in the chat window of what might happen, how
yeah,
this might different if the student starts paying a constant amount.
and I could say kids like have no idea. They've been told credit cards are evil.
Mm-hmm.
So like some of my students, they won't even consider the situation. I have to say, but wait, at some point in time, you might buy a car, you might buy a house. It's the same idea on a different scale.
Yeah. So we're
And so
getting
we have
change the
to,
slope, and we're
yeah,
getting becoming linear. Wouldn't be exponential anymore.
right.
Now,
And this is
this
what
one
we want to
threw
do with
me.
our students too. Like,
Yeah.
what's going to happen now? Are we ready to try?
Yeah.
All right. So when I do that, come on, computer. Let's hit enter again. Wow.
Oh. Now,
That's
don't let
that's
that
kind
red one fool you. The amount you total pay doesn't go off. That's just because we hit negative. But did we just go from
yeah,
concave up to concave down?
we did. Let's go ahead and hide this red one real quick. In fact, I'm going to turn it off from the menu.
So we're
Yeah, we
decreasing
did.
at a greater magnitude of rate each month, right? That
Yeah,
payment is going down. That is something else. And it's not quite linear because that credit card company is still adding on a little bit of data. But gosh, we're dropping fast.
that's a huge drop right there. So if we go back to our accumulation, that's in my U2 here. So again, we did +1, and so we're taking how much we paid. So the very first time we paid 0, right? We start out with 0, and we're not adding in 8% of anything anymore. This time we are constantly adding in 250. And so now what's this graph going to look like? And there it is. There's our linear, because we were constantly just paying 250 each time and adding 250 to 250 to 250 to 250.
Can you trace the blue until we're paid off and then find out how much we totally paid?
Shall I change the months right now? Get rid of the
Sure.
61 real quick.
Oh,
You have a guess?
so 5 years into the future is not too much. I don't know. How quickly did we pay off?
Well, let's go with
Anybody got an idea?
36.
36?
Oh, wait, maybe we have better suggestions. You
Don't have
started with
any yet.
48 before. I'm going to put 36 in there just for fun, just to make it a little bit bigger there.
Yeah.
And this is from something else, which I don't know why it's doing that, but I'll hide those real quick. And so we're going to go menu, and we're going to do trace, graph trace. And so let's see where we're at. So I have 3,000, then 2840, 2675.2. So we could put that into a table. We could look at those and see that there's still that little being added to it. But if I correspond to month 3 or payment 3, oh, it doesn't go exactly through that. So if I'm in the red one, we have 250, 500, 750. So we see how that increased up there.
Now, we had
Did you
a
want to see?
suggestion earlier that we would see that linear rate, and we're
Mm-hmm.
seeing the linear in the increase because that one is, we're adding that 250 every time, that constant rate. So 16 months. Really?
Yeah.
In less than a
And we
year and
only
a
have
half?
$24. We have $24 left.
We can take that extra of that 24 that we don't have to pay the 250 and start saving. So how much total did we pay off at 16 months? How
All
much
right,
total
let's
did
go
the
back
credit
up.
card come?
37.50.
37.50. That is
That's better than
significant
before.
savings.
That is
Yes.
much better than
And even
before.
better is that money that we were giving the credit card company can now go back into our bank account. That's nice.
That's beautiful.
Yep.
So this is a reasonable situation to talk about the numbers and the math to then connect back. And what's most important is like doing a recursive process here that does connect to the real world. I know a lot of people would argue that we're supposed to be doing finance in all of our classes, and this is accessible at different levels. Like we could do this with freshmen in a recursive sequence, maybe not all of the steps, and then build upon that. But again, it does connect to other pieces, other concepts that are recursive. And you mentioned before using Euler's method, which some people teach with the chart and moving on from there.
Yes.
All right, so are
All
we
right.
ready to move? Like we had another example that was
Yeah.
just kind of connected to this, right? And kind of talking about those connections to calculus. And this is a differential equation, and you can kind of see the theme to this. Suppose a deer population grows exponentially at a rate of 10% per year. Like just a made up situation. I have no idea how deer grow or where they're at and all of those other things. But to keep the population size reasonable, the Park Service removes 20 deer each year. Write a differential equation for the rate of change of the size of the deer population with respect to time. So that's a skill that is listed in the course exam guide for AP Calculus. But even this story, I know a lot of times my students will go, what the heck is this talking about? And you have to go story. Had they gone through the finance example, I can totally see how that's parallel to this one here. All right. Any ideas? All right. So I think we're ready to go to some geometry.
Yeah.
All right. My favorite. And so we have one more story that's going to connect us to geometry, and we're talking about area. And so we have a story where we're kind of looking at the area of inscribed polygons. So I want you to think about the equilateral triangle that is inside of this circle. So it's inscribed in the circle. And there's a lot of extra space that's not covered by that triangle. And as we increase the number of sides to 4, now I have a square inscribed inside of my circle. So in the geometry world, we can construct these things. We do lots of different things. This problem shows up in a variety of ways as we go through the curriculum, or even just exploration of geometry. And there's less space compared to the triangle that's in that circle. And then if I go to a pentagon, you can see that I'm closing in on that space, getting closer and closer and closer to that circle. And so this visual right here gets us to 12 sides, 15 sides, 18 sides. So we can see that we have, as we increase the number of sides, it's getting close to a circle, but this is still truly a polygon here. And so does anybody know which story we're really kind of getting at as we're increasing the number of sides? Okay, we'll go
This
ahead
is a
and think.
really old story, isn't it, Kim?
It's a very old story. And,
I
and
think
it's
it involved
one
a
that,
guy that liked to wander the streets in his towel.
yeah, and sometimes this comes up like in March quite a bit, like we end up telling this story right here. So, and it depends on which punchline we want for the story. So
Yes.
someone's suggesting it looks like it's a way to estimate the circumference of a circle, but and it could be. We are definitely looking at
Yes.
area. Now, connecting to calculus, yes, calculating to pi, that is the one. In fact, I just showed a little video to my students that kind of started a little bit about pi. But in geometry, we have inscribed and we increased the number of sides. It's going to look more circular. We kind of did a little bit of an example of that in the first one. Let's go ahead and go with the fact that the circle's inside of the triangle now, so that we have the other situation here. And so we still have a lot of space outside of that circle. And we put a square around it, less space around the circle that's not kind of wasted if we're like cutting out something. Here's our pentagon. And so as we're increasing the number of sides of the circumscribed polygon, we can see that we're getting closer to the shape of a circle right here. And so we're approaching that area of that circle is really what we're going to be looking at. So we are kind of looking at that area piece right here. And what's super valuable as we talk about this in our calculus class and we extend this relationship is if we kind of put both of these together, we have a good application of the squeeze theorem here. We have an application that students can really connect to, because as we increase those sizes, we can see how the inscribed and the circumscribed are approaching that circle from above and below. And so what we want to do is we want to take this and go ahead and put this in our TI-84. So I'm going to give this back to you, Dennis, as
All right.
we kind of fill in our charts.
Yeah. Okay. Let's see. Do I?
Getting there.
So this connects back into sequences again because we only have discrete number of sides for that polygon. We're not going to have a regular polygon with 3.5 sides or with an irrational number of sides. And so we need to look at the increasing area as a sequence. And so just in the quick amount of time we have, I'm going to do one thing with my emulator just to save time. I'm going to reset my emulator so that all my
And that's
list
an
is gone.
and that's an
What?
important thing to
Go ahead.
do in your classroom in between classes sometimes, just
Yeah.
to
What
start over.
What I like to do, if you're the SmartView user, I like to set up my calculator the way I want it for that day. Because if I'm teaching 3 classes, they're all the same, and it all gets out of whack. What's great on SmartView is I can actually save that emulator state, and every time I'm just going to open up my emulator state that I save for that day. So I just reset here so that my data's gone, and now I'm in a different mode, and I'm back in function mode. But what I'm going to do, because this really pays dividends for my geometry students. When I do this in pre-cal, I do this in pre-cal during my limits unit they don't get as excited that pi jumps out because we're measuring the angles in pi. But if we measure the angle in degrees, we're going to get to see where does pi come from. So I've done that. And just a quick thing, we don't have much time left, but just to show you what we're doing is we're having our students calculate the area of that one triangle. We've got a base of r. We got a height of r sine theta. And so there's the area of my triangle. And then if we make the radius 1, and then the angle is 360 degrees divided by the number of sides, then this is the area of my polygon. And so what I want to look at is going real quick, going into this list. So I'm going to press Stat, and I'm going to go Edit. And I want us just to see that I can use sequence commands to fill these. So I'm going to go up to L1, and I'm going to insert a sequence. That's under my list menu. So I'm going to press second stat for the list menu. Go over to ops, and I'm going to do 5 for sequence, and I get this nice sequence wizard. Well, I got a variable x. I'm just counting up the variable x as x goes from 3. Won't start any earlier because it is a polygon. And I'm just going to go to 12 now. And then I go down, I press paste, and it goes ahead and puts those values in there, very much like you might see in a spreadsheet. And then I'm going to go over to L2, and I'm going to press enter there. And I'm going to put in my formula for the area based on the values of L1. So this is what I'm going to do. I'm going to do second 1 to get L1 divided by 2, and then times sine of 360. Oh, I'm sorry, 360 divided by that same value in L1. So second 1 again. And when I hit enter, I see these values, and they're approaching pi from below, which we expect because this is our inscribed polygon. I don't have time to put the other one in. I might be able to pass the ball to Kim. I think you have that up, don't you, Kim? Do you have
I
the two
do.
sequences
I
in?
will
All right, so I'm
pull
going to
that in real
plot that
quick.
while you have that ready. I'm going to hit
Okay.
plot because that's the default. And we'll just go back to our Zoom stat that's been a friend tonight. And we can see that this is starting to level off. And I can increase the number of plots. So instead of going just from 3 to 12, I could change that to go from 3 to 20 like we saw in the visualization. And then I can go ahead because I'm in function mode, and I could graph pi right there, and I can see this asymptotic behavior. And when you get them both, as Kim's going to show us real quick, we get a nice visualization of the squeeze theorem.
Right. Okay, we don't need to talk about deer. We want to talk about polygons here.
Ah, there
So
it is.
there they are. So the other formula involves tangent. So n tangent 180 divided by n. And we're using degrees. And what I loved about using degrees is you didn't have a pi anywhere, but it is approaching pi. And I
Yes.
just graphed that horizontal there so that we can see it approaching it from above and from below. All right, I see that we're like right there at time, so I think it's time to hand
Yeah.
it back to Mike.
Thanks, guys. I'll take it.
Awesome. Perfect.
So as promised, tonight we're giving away to one lucky winner a TI graphing calculator, and tonight's lucky winner is Robert Baker. So Robert, congratulations. We'll be in touch over email in the coming days to give you a little more information and to figure out which one of those TI graphing calculators you'd like to receive.
Congrats. That's awesome.
For sure. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed as a link for the documents that Dennis and Kim used tonight. And if these links aren't working for you for any reason, just hang tight. You'll automatically get a follow-up email with links to the recording so you can go back at your own pace, links to the certificate, and links to the documents. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. When you leave the webinar site, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you share your thoughts in the post-webinar survey. That's how this webinar came to be as a part two. You guys asked for it after part one, and thanks so much to Kim and Dennis for putting their heads together and making a part two.
Thanks, Mike. It was been great. I've enjoyed working with Kim and being with you guys tonight.
Yeah, thanks, Mike. It's been fun, and I want to say that I think more sequentially now than graphically sometimes.
Yeah. I'm more discreet in my thinking now.
I'm laughing inside. So
Yeah.
thanks so much for joining us tonight. And we hope to see you back online next week. Stay safe and have a great night.